Hello, my lovely viewers. You are welcome to TBN Math class. In today's lesson, we're going to look at quadratic functions, specifically completing the square to find the quadratic formula. So in today's lesson, we're going to look at how to use the method of completing the square to prove the quadratic formula. When we say a quadratic function, what is it? Quadratic functions are written in the form y is equal to ax squared plus bx plus c. So looking at this critically, you can see that a quadratic expression or function is a second degree polynomial function. Why? Because it has the highest degree to be 2. Now, when this is written as ax squared plus bx plus c equal to 0, it becomes a quadratic equation. And we use quadratic equations to prove the quadratic formula using the method of completing the square. So let's see how to go about it. When you have a quadratic equation like this, and you want to use it to prove the quadratic formula, there are steps to follow. What are the steps? Step 1, take the constant term to the other side of the equal sign. When we say the constant term, what is it? This is the constant term, the c. So it will be taken to the other side of the equal sign. We are going to have ax squared plus bx is equal to negative c. Step 1 has been dealt with. Step 2, make sure the coefficient of the x squared becomes a unit. Making it a unit means that make the coefficient of the x squared 1. Now, what's the coefficient of the x squared? It is a. So here should be changed to 1. What do we do to change that place to 1? We will divide here by a. And we cannot divide only this by a. This one has to be divided by a. This one too by a. So when a cancels a, you will have x squared plus b on ax equal to negative c on a. What is our next step? Now we can see clearly that this is 1. Now what's the coefficient of the x? It is b on a. Then the constant is now negative c on a. In the next step, what do? We pick the coefficient of the x, which is b on a. What do? We multiply it by half. B by 1 will be b. A by 2 will be 2a. Having done this, that is not all. We now square the result. So squaring this will be b on 2a all squared. So what it means is that you pick the coefficient of the x, which is b on a. You multiply it by half, which is b on 2a. The result is squared. That is what you do. When you get to this level, don't square them. Leave it like this. So we can see that now we have b on 2a all squared. Now the b on a, it is always multiplied by half. It doesn't change. So always multiply the b on a by half. Now what do we do in the next step? The result that you have here, listen and listen well, my viewers. The result that you have here, you add it to both sides of the equal sign. So what do I mean by saying that? You add it to this side, you add it to this side. So let's see what we get over there. You have x squared plus b on ax. So what do? We add this one to this plus b on 2a all squared. When we go to this side, we will add it to this, but because this is minus, let's write this one first. So it should be b on 2a all squared minus c on a. So you can see that We have added it to this side. We have also added it to that side. Now, what will be the next step? We will now simplify what we see at the right hand side of the equal sign. But what do we do to this? At this point, the terms with squares will be written together, then we square them. So it will be x plus b on 2a all squared. Someone may ask, where is this term? The moment you write it like this one has been fused into this. In other words, when this one is expanded, you get this expression. So when you get to this level, don't think that this one has been thrown away. It is in this. So you pick x, you pick b on 2a, that is those with squares, you write them together, you square them together. The expansion will give you this. And this will be equal to, how do we simplify this? We simplify this by squaring this, squaring that, because the square affects both the numerator and the denominator. So squaring b will be b squared. On here, you have to square 2 and also a. So squaring 2 will be 4. Squaring a will be a squared minus c on a. At this point, what do we do? Because this expression has an operational sign minus or subtraction, we will find the LCM of the two. So let's write this one. We have x plus b on 2a all squared equal to, now when we find the LCM, we will get 4a squared, because that will be the least common multiple of the two. The 4a squared goes into this 1 because they are the same. Now when you get the 1, you multiply it by the numerator. Multiplying 1 by b squared will be b squared minus a will go into 4a squared, 4a. Why? We have 2 a's here multiplying. So when a cancels one of the a's, it will be left with 1a with a 4. So we will have, and now when you get the 4a, it has to be multiplied by the c, the numerator, and that will be 4ac. Now let's write the expression here. We have x plus b on 2a all squared equal to b squared minus 4ac on 4a squared. Because our main attention is on making x the subject, and it has been covered by a bracket with a square, the square has to be gotten rid of. So how do we get rid of squares? We bring square root here, then we square root this one as well. So the square will take care of the square root. What do we have here? X plus b on 2a, and this will be equal to, anytime you find the square root of an expression, the result becomes plus or minus. So it will be plus or minus in a square root, b squared minus 4ac all on 4a squared. At this point, looking at this, we can see clearly that the denominator is a perfect square. Why is it a perfect square? And what is a perfect square? A perfect square is obtained by squaring an expression. So when you square a certain number, it gives you 4. When you square a certain term, it gives you a squared. So when you square a, you get a squared. When you square 2, 2 gives you 4. It means that the square root of only 4 will be 2. The square root of a squared will be a. So at this point, we will write x plus b on 2a equal to plus or minus. So the square root will cover only the top one. B squared minus 4ac divided by 2a instead of 4a squared. We have found the square root of the 4a squared, and that gave us 2a. Now at this point, because we want to find x, we will group like terms. It means that the term without x will be taken to the other side of the equal sign. So x will be maintained here. And because we have plus or minus here, let's write this one first. So we are going to have minus b on 2a plus or minus in the square root b squared minus 4ac all on 2a. So at this point, because we have a term, and in between the two terms, we have plus or minus, we need to simplify this. How do we simplify an expression like this? Because the denominators are the same, the numerators will be simplified. So it means that x will be equal to minus b plus or minus in the square root b squared minus 4ac all on 2a. So we have made x the subject. Hence, the formula, that is the quadratic formula, has been obtained. And it is x is equal to minus b plus or minus in the square root b squared minus 4ac all on 2a.